Hello and welcome. My name is Navneet Joneja. I am the lead product manager for Compute Engine.
And I am Martin Gannholm, the engineering manager for Compute Engine.
Over the past several months, Compute Engine has evolved to become faster, better, more cost-effective, and easier to use. And we're here to talk to you about what that means for you as a developer and for the applications you can build in the cloud. Now, a quick note about level of depth. This is a short session, so the goal here is really to make this a fire starter. We're going to talk to you about what Compute Engine is about, talk to you about several of the new features, but not go into a significant amount of technical depth on them. We have additional deep dive sessions about everything we're talking about today, and we'll give you pointers to the sessions at the end of our talk.
And we also have a Q&A at the end, so you can ask as deep a technical question as you want then. OK, so let's start talking about infrastructure. So this is a picture of one of our data centers. And this is the infrastructure that everything Google does as a service runs on. Now, our infrastructure includes both the hardware and the networks that we have, but it also includes the software infrastructures that we have built. And Urs talked about some of this earlier today. This is the infrastructure that powers our web search. It allows us to crawl more than 20 billion web pages every single day. It's the same infrastructure that also serves up more than 4 billion hours of video every month. It also is the same infrastructure that powers Compute Engine and the other cloud platform services. And so you get to take advantage of running on this infrastructure that we have developed over the last 14 plus years when you run on Compute Engine. So let me cover a few of our core principles. Being highly secure is one of our fundamental principles. And so that takes three forms. One is encapsulation. The primary form of encapsulation is, of course, your virtual machine. We also encapsulate the network. So all of your Compute Engine instances are connected to each other on a private encapsulated network, and they're connected regardless of which zone or which region across the globe your instances are running in. The second dimension is access. We restrict access to your virtual machines by default, and so the only port that is open to communicate from the outside world is through the SSH. Now, you can choose to open up other ports in the firewall to allow other traffic in. You can also choose to remove your public IP address from the instance and thereby cutting it off from the internet, and you can only reach it from other virtual machines inside of your cluster. The third form of security that we employ is encryption. So all of the block device storage that you use, whether that is the scratch disk or persistent disk storage, is encrypted at rest, and it's encrypted as it leaves in the virtual machine monitor and before it hits the disk.
So at Google, we treat performance as a first-class feature. It's not just another attribute of a service. And this goes back to our early days when we designed our consumer sites to be as fast as possible, because we believe that there's a strong correlation between speed and engagement. And so it reflects itself in the infrastructure we build. Our physical machines are built to be very fast and very consistent. And it reflects itself at every step of the stack. So not only do you get to build on great infrastructure, the software itself is architected to be highly consistent and highly performant. So how does that show up in Compute Engine? Well, first, it shows up in the performance of the virtual machines you can launch in Compute Engine. So you can launch a 2-core virtual machine anywhere in Compute Engine and get the same performance. So the consistency and the performance are both attributes built into the architecture of Compute Engine. It also is present in our storage layer. Now, in many cases, the performance of the storage layer is at least as important as the performance of the actual virtual machine. And so we've built both our scratch and our persistent disk solutions, which are short-lived and sort of highly available, redundant, reliable storage solutions, to be very fast and very consistently performant. And this has been demonstrated by many benchmarks run by some people in the audience today even. Another aspect of performance for us is network performance. Now, network is really what Google does, right? It's fundamentally core to all our businesses. And so over the past 14 years, we've done a lot of research in the area of networking. We've published several papers. This morning, if you were at Urs's talk, he was talking about how we run on a software-defined network for all of Google. And you'll find that that research and that thinking about network performance is pervasive and is reflected in Compute Engine because when you spin up virtual machines, you get extremely high cross-sectional bandwidth between virtual machines in Compute Engine, and you also get great performance to the broader network as well. Finally, we also believe that scale and speed of scaling is important because it turns out that you don't always get a heads up about load that's coming your way, right? By the time you know you need to scale, it's often too late. And so when you need to scale, you want to be able to spin up virtual machines as quickly as possible. And so we've focused on making that spin-up process quick and painless so that you can scale up quickly and effectively on Compute Engine. So how does that reflect in the product that you get to use? Well, so a great example is our partner MapR Technologies, who used our off-the-shelf virtual machines to run the benchmark called the minute sort benchmark. Now, this benchmark measures how much data you can sort in a minute. It's kind of the gold standard for big data processing. And MapR was able to sort 1.5 terabytes of data in 1 minute on Compute Engine, beating the previous record that was set on dedicated, tuned physical hardware. So I hope that gives you a sense of what you can do when you have access to not just fast virtual machines, but to a fast network connecting those virtual machines.
All right, another core principle is openness. We start by providing an easy-to-use API layer that we expose to you, the developers. Now, that is also the same API layer that we use as we build higher level tools. For example, command line tools or the Cloud Console is built accessing the exact same APIs that you have access to. Another form of openness is we really want developers and partners to be adding to the ecosystem, building solutions on top of Compute Engine and the greater cloud platform. And so we've worked with the community to provide both CentOS and Debian images as part of Compute Engine.
Now, all that doesn't really mean very much unless it translates into benefits that you can see and that benefit you. And we're very happy that our customers and partners have noted that our focus on performance and security address what they're hearing from their customers as their top concerns when they move to the cloud. Here's a quote from Thorsten von Eichen, the CTO of RightScale, one of the largest providers of cloud management software.
So Compute Engine is not an island. I spoke earlier about the cloud platform. So to build really sophisticated services, you often need to use multiple different pieces in order to build a complex application solution. And so we're really excited that today we announced that Cloud Datastore is basically taking what has been the world's largest hosted NoSQL database, which is App Engine's Datastore, processing more than 4.5 trillion operations per month, and making that available through a public API. So you can access it from Compute Engine or indeed from anywhere. And so you can build applications comprising front ends using App Engine, communicating and sharing data in the middle with the Cloud Datastore, and having back ends on Compute Engine, for example, all being synchronized and accessing that data. So there are a lot of possibilities with Datastore. So we think it's a great addition to the family.
And that pattern that Martin talked about is also a great pattern, one that we recommend because it lets you get the best of both worlds, App Engine for your scalable front ends and Compute Engine for the heavy lifting. Now, it turns out that not all workloads are created equal. Some, like databases, benefit from lots of memory. Others, like rendering or processing geographical data, require lots of processing power. When we launched Compute Engine, we launched with what we called our standard family of instances, which had a good mix of both processing power and memory. But we quickly specialized to offer instances that actually are more suited to these specialized workloads that require more of memory or compute. And so we launched instance families called our high CPU and high memory instances. So you have a good diversity of instances to suit a broad array of workloads. And the standard instances are available in 1, 2, 4, and 8 core variants. And the high CPU and high memory instances are available in 2, 4, and 8 core variants. But that's not all. Today, we are also announcing 2 new instance types, our small and micro instances that are designed for workloads that don't need as much processing power. So for example, if you want to run a development or test workload in the cloud, or you just want to experiment, you can do so with these instances for less than 2 cents an hour.
So as you design your clusters and think about how you're going to orchestrate and get a large number of machines understanding what their roles are, we produced a metadata server, which is a simple HTTP server that's exposed into the guest environment. So you can just use a simple HTTP GET request to get metadata that is passed. Now, we had 2 forms of metadata. One was project level, which all of your instances would see the project level metadata. And then we also have instance level metadata, where each individual machine can have custom metadata for just that instance. Now, one of the things that we've now added is the ability to mutate this metadata and add more metadata on the fly. So you can use this to pass in changes to your configurations while your system is running. You can also use it, the instance itself can also make changes to that metadata to pass information out to some process on the outside that wants to understand what's going on with the instances.
Now, it turns out that a lot of people, try to solve these problems in their own self-built clusters by using things like agents to configure and to update instances when things change. And with Compute Engine, because you have access to a metadata server that's very easy to program to, you don't need to do that. It's built into the service. Another thing people think about a lot when they think about how they deploy sort of highly robust and scalable architectures is how to make their applications restartable, repeatable, and resumable. And so from the get-go, we provided a highly reliable persistent disk solution to let people store their critical data so they could do these things. And our customers really liked it, and they wanted more. And by more, I mean more storage. And so today, we're happy to announce that you can now attach up to 10 terabytes of persistent disk to any Compute Engine virtual machine, which really lets you unlock the power of crunching large amounts of data and storing that data reliably. But it's not just about your actual application data. It's also about your virtual machines, too. And so we've made it possible for you to use a persistent disk as a root file system for your virtual machine. What that means is that if you deploy a virtual machine as a component in your architecture, and that component happens to fail, because they do, that's Murphy's Law, you can always bring that component back up in practically the same state where it left off, because all the configuration tweaks you made to that virtual machine in the root file system, all the changes you made to it were preserved, and you just spun up a new instance using the same persistent disk, and it's effectively the same instance. Take that one step further, and think about what you can do when you can actually attach and detach these persistent disks on the fly to your virtual machines. Because now you can think about architectures like having a hot standby, where you can quickly swap a persistent disk to a hot standby and have very low downtime if a component fails. Or think about what that means in terms of how you scale. So it's quite easy to scale horizontally, but if you want to scale vertically, you can even do that. So let's say you're running a database on a standard instance, and you decide that you could probably use some more RAM because your queries are not performing as well as they could. So you spin up a high memory instance, and you detach the persistent disk from your standard instance. You attach it to the high memory instance, and you've just scaled vertically. So persistent disk makes building these architectures really easy. And with these changes, we hope that it'll make your applications ever more robust and easier to build.
Right, so the cloud is all about flexibility. And so you can spin up a single instance or 1,000 instances at the drop of a hat as your workload demands. Now, with sub-hour billing, which we announced today, you pay for per-minute increments. And this gives you flexibility also in the time dimension. No longer do you need to think about utilizing the full hour that you will pay for, and you can instead focus on exactly what your workloads require. And so we anticipate that this will enable new types of use cases when you can spin up your virtual machines really, really fast, and when you turn them off, you only pay for the time that you actually used.
And when you combine that with the fact that virtual machines spin up really fast in Compute Engine, that can actually enable new kinds of architectures, as Martin said, that we've seen at Google, and in fact, it's how we build our applications, but we haven't really seen much of in the cloud, and we hope that this enables you to build using on-demand kind of architectures, which you couldn't earlier. Now, a lot of our customers told us that they don't look at the cloud as a silo. They want to build applications that span their local infrastructure, their own physical data centers, and the cloud. Or in some cases, they want to build applications that span clouds. And so we've announced a new feature called advanced routing. It's a very deep networking feature that lets you do lots of things, including this. You can actually spin up gateways and VPNs, so you can connect your data centers to the cloud and sort of share IP spaces so that you can do things like augment your on-premise capacity with capacity in the cloud, build multi-cloud deployments, share data between applications that might live in different locations, and more. You can also do things like, as Martin mentioned earlier, if you remove the public IP from an instance, you can cut it off from the internet but make it accessible from inside. And now using advanced routing and the fine-grained packet level routing control you get, you can do things like deploying a proxy server or a gateway to mediate access to those instances. So it makes some very, very cool and powerful and highly secure architectures possible when you take full advantage of this capability.
All right, what I want to do now is to give you a little demo of some of the features that we've talked about. So I'm just going to switch to this one. Uh-oh. Yeah, I know, but it's no, it's not refreshing. I broke it, Joe.
Well, you know it's a live demo when stuff breaks, right?
Totally blank. Oh, I moved to that one, but. Open up another tab.
All right, we'll try and get this fixed. In the meantime, we'll just move on to the next segment, and we'll come back and get the demo going. I'd like to invite Sebastian Stadil, the founder and CEO of Scalar, to talk to you about what he thinks is cool about Compute Engine.
All right, thank you very much, Navneet, for inviting me. So it's very exciting to be here. I'm super pumped about getting a Chromebook and all that. So I hope you guys are as excited as I am. So I'm here to talk about a couple use cases that we've seen from our experience at Scalar with working with hundreds of customers across many different clouds for the past 5 years now. And there's a lot of features that Compute Engine has that basically allow us to solve real customer problems with greater ease. Yeah. So here's a few of the customers that we've worked with in the past 5 years. Companies big and small. You can one of them that I'd like to point out is Samsung. They run something like 22% of the world's Android phones. They build applications to manage all of that, and infrastructure for it is just huge. And I'd like to I'm super excited because right now, as I speak, there's the Eurovision contest, which is a how many of you here are from Europe or have heard about this contest? Awesome. So it's like the world's second largest annual event, annual televised event, between 100 and 120 million televised viewers. And the voting for it is extremely spiky. Now, the viewership on any given day for this is 4x what you could find at the Olympics on any given day. The scale of this event is so huge, I could even say it exceeds Michael Arrington's ego, but maybe that's a bit. So Ralph Rothman, the infrastructure director for Compute Engine, that was retained by Eurovision to run the backend for this, has the following to say of Compute Engine. Google Compute Engine rocks. Basically, what he loves about it is it's not just fast, it's Google fast. There's a few recent benchmarks that we ran to evaluate the speed of different services. And one of the figures I'd like to show is that for sequential I/O on persistent disks. You can see here in blue is Google, higher is better, and it's compared to a well-known competitor. You can see that, and you can see here that for sequential writes, you get about 3 times the amount of throughputs. For reads, you get about twice the amount. This type of performance is something that's really valuable when you're using Cassandra or anything that writes sequentially. But Compute Engine isn't just about the speed, although we love it. It's also about the features. And there's this use case that we see recurring in the enterprise, which, think about it this way. You're building an application on the cloud, and that application needs to access some resources that you have in your corporate network. Now, normally you'd have to build a whole series of things to get that and secure that and go through all sorts of different vendors. Compute Engine's routing capabilities allow you to do that really, really easily. They allow you to build that highly secure tunnel between Compute Engine and your corporate network for your application. Another use case that we see very often is the opposite. When you have applications that are in your corporate network, but don't have enough capacity for them to run because they've increased in size. And what you have here is you usually have something called cloud bursting, where you're extending your corporate network with cloud resources. Again, routing makes this really, really easy. A second use case that we run into quite frequently is the processing of large amounts of data. The folks at CERN, specifically from the Lawrence Berkeley labs just across the bay, they're working on the Atlas experiment, which is responsible for managing all the giant Condor clusters that are crunching huge amounts of data. And that eventually led to the discovery of the Higgs boson particle. Now, they crunch huge amounts of data, and when you're able to mount a persistent disk to multiple instances, and when you couple that with the new limit of 10 terabytes per persistent disk, it makes it really, really easy to crunch a huge amounts of data across the large amounts of nodes without having to manage a very large number of volumes and having to version what's what, where, and all that. So the use case of crunching large amounts of data is very much facilitated. Now, there's another use case that I like to talk about. So this is the third one. And I'm sure if anybody here has used one of the leading competitors, a couple years ago, there were two major outages that pretty much took a lot of people offline. And when we had some customers that were telling us, well, this is unacceptable, there's a lot of components that are not reliable, so we need to architect around that. And architecting around those things is very, very difficult. For example, if you can't rely on a region being up, if you can't rely on remote disks being accessible, then you have to architect around that. And that's really, really, really tough. It's very painful. I'd say it's like probably even more painful than sitting through a Twilight movie, but I don't know. Yeah, so the fact that you have that in Compute Engine, you're able to have every resource that's either a global resource or a regional resource, that allows you to plan what will go down in the event of a regional outage and what won't. So you can plan your architecture and build your infrastructure in a so it makes it much easier to build highly available systems. And finally, the last thing that of course, as a startup that I'm very much appreciate is the by-the-minute pricing. We have this customer that has very, very erratic scaling patterns. They're very hard to predict, but when they happen, they're just explosive. So they go from X to 20X in the matter of minutes. Now, what's awesome about by-the-minute pricing is that it dramatically reduces the risk of scaling up. If you only need to pay for that 10-minute block instead of the whole hour, then you can start scaling at the slightest hint of having that peak. So we're looking at about 6 times lower cost of a false positive here, so that's huge. And eventually, that's all that money that you start saving, and you might be able to do cool things like buy a WinZip license, or I don't know, but that that money ends up. So that's the 4 use cases that we see Compute Engine being really powerful, and we're super excited about what you guys are building. So I'd like to hand it back to Martin.
Thanks very much,
right.
Sebastian.
Thank you, Sebastian. All right, Joe fixed it. Thank you, Joe. I was going to show you a little demo here, highlighting some of the features that we have. And I'm just going to start by kicking off a bunch of VMs, and I'll talk through what's happening here. So what you're looking at here is a web page that is backed by an app engine application that is controlling the compute engine API, compute engine through the API. And so what it did is on the left-hand side, it started up a cluster of 1 instance, and on the right-hand side, it's a cluster of 8. And so you can see, as it's coming up here, the green means that these VMs are actually running, and they are now just getting ready to be able to serve tiles in a Mandelbrot set. So we basically are going to show you some cool Mandelbrot fractals here. And so on the right-hand side, this 8-machine cluster has shown up, and here on the left-hand side, we have the single instance has launched. So you see, that's how fast we can launch a bunch of instances on Compute Engine. And these are now 2-core high CPU instances. So let me show the map. So we're using the Maps API here to basically just jump around and get some tiling behavior. And you can see that the right-hand side is a lot faster. Now, I'm just a single user using this, and so it doesn't demonstrate the full scalability of this. And so if it was a multi-user, multiple users hitting this at the same time, you would see the scalability much better, but it's pretty cool anyway. Ooh, this is one of my favorites. This is pretty complex. This one takes much longer to render. All right, so one of the interesting things here is that the virtual machines are vanilla images that we launch, and all of the configuration data, all of the instructions for what they should be doing are passed into the virtual machines through our metadata server. And so, in fact, since this is a Go program, we're actually passing the source code of the Go program in one of the metadata values, and that gets read by the virtual machine as part of the startup script, and it compiles it on the fly, and then renders these things. So that's an interesting use of our metadata server right there. So let me show you what happens if I go over to the Cloud Console. So the Cloud Console is a new home, and actually let me go back here, a new home for all of our cloud services where you can manage and see all the resources that you are using. You can see billing information and all this kind of stuff. And so I'll just jump back into the Compute Engine piece. And here we see a list of our instances. And so right now, I have 8 instances here, and then I have a single one over here. Now, what I can do is I can add virtual machines, and we've programmed this so I can just click this button, and it'll start spinning up virtual machines here. And one of the things that I'm previewing for you here today is it says using load balancer up at the top. And so this is a upcoming feature of Compute Engine that we are showing you where it's a load balancer as a service. And so adding virtual machines is really easy. You just spin them up and add them to your pool of servers for that work. And similarly, you can remove machines. And so as I click around, those things will be spun up. And I should have been doing this while it was coming up. But as they get health checked, that's what the white check mark means, they basically get included into that. Another fun thing I can do is I can, of course, just go into any one of these instances. We can look at this, and here you can actually see the Go program. It's really quite long, but we can't see the whole thing. It's one of the metadata pieces. And I can just simulate a failure. So I'm just going to delete this instance. So we'll blow that away. And now, as I'm scrolling around and doing stuff here, you'll notice that everything still keeps working, and our application detects that machine is gone. So it highlights, it updates the little graphic we have there. And then, of course, I can just spin everything down by hitting the stop VMs right here. And as you see, in this view, you'll start seeing these things terminate and disappear. One other thing I wanted to point out here is that you'll see a metric being shown on this graph, which is CPU utilization. And so this is another preview feature of an upcoming Compute Engine feature, which is a monitoring API, where we will expose a number of metrics out of the virtual machine, and we will add to those metrics over time as well. And now all our instances have shut down. So I think that's it for the demo, and we'll switch back to slides.
Thanks, Martin. And thank you, Joe. So as I mentioned earlier, this is an overview session. We haven't had time to go into much technical depth about any of the features, but we wanted to give you an overall flavor of Compute Engine. But we have deep dive sessions into a number of things that we've talked about today. Speed, efficiency, and control is a deep dive session on our advanced networking stack. I highly encourage those of you who are interested in this stuff to go and attend. It's going to be a really cool talk. We have a great talk on persistent disk later this evening, actually, where they're actually not only going to tell you how to use persistent disk and talk about using it in an application, but even give you a little bit of a behind-the-scenes glimpse at the architecture and the product itself. We have a session that is focused on how you can build robust, high-availability applications in the cloud. It's called When Bad Things Happen to Good Clusters. And then we have a code lab on Friday morning, which will help you get your hands dirty with Compute Engine, play around with some astronomical data, and just get a feel for the product. It should be a really cool, fun session. And of course, we have some time for questions today. But we'll also be at the sandbox from time to time, and we have office hours tomorrow. If you want to come by and chat one-on-one, ask any question you have of us, we'll be available to you. So one more thing. So we're happy to announce that Compute Engine is now available to sign up online. We'll be flipping the switch shortly after this talk. You can go online, sign up for Compute Engine, play with it, spin up a virtual machine for under 2 cents an hour. Tell us what you think. Tell us how we can make the service better for you. We'd love to have you play with the service, give us feedback, and tell us what you need from it. Now, if you're interested in playing with the 2 new preview features Martin talked about earlier today, the load balancing capabilities as well as the monitoring APIs, we actually have them available to a small set of customers. And we'd love to have more people come play with them, give us feedback, help evolve these features, tell us what matters to you. So we have an early access program. The URL is on the screen up there. Come apply, give us feedback, be vociferous, tell us what you like, tell us what you don't like, especially what you don't like, so we can make it better for you. Thank you very much.
All right, thank you. And I think we can take questions now. I would like to invite Sebastian back up on stage, and also Joe Bida, who is the tech lead on Compute Engine, who will field the most difficult technical questions.
So, why did it fail? Does anybody want to know? I was running it on an unpaid App Engine instance, and I hit a quota limit. And so I entered my credit card up here frantically while you guys all watch. So. And in that vein, I'm going to be hosting the robustness talk later.
All right, we can start with you.
Maybe this is a question better for the persistent disk session, but I'll just ask it anyways. What's the consistency semantics associated with multiple Google engines writing to the same persistent disk? Let's say they're writing to the same file.
So you can only attach a persistent disk read-write to a single instance at a time.
Okay.
We do have the capability of mounting read-only a single persistent disk to many VMs at the same time, but that's in read-only mode. So you can share data across them that way.
Okay. And you're free to do something like run an NFS server on an instance hosting a persistent disk and then export that to other virtual machines if you need to share a file system.
And in our benchmarks we run, there's no degradation of performance when you're reading it from multiple servers.
Thank you.
All right, over here.
What is your plans with Google's customer support surrounding this whole thing, given the history of Google and customer support?
So we've already launched the ability to get premium support. We have a gold support program. We launched that about a month and a half or maybe 2 months ago. So you can actually get developer support, talk to a real person on the phone, as well as submit tickets. So that's already a capability you can have. We're also very responsive to feedback, and we watch Stack Overflow and stuff as well. So if you have sort of non-urgent development questions, we're quite responsive.
All right, fine.
You mentioned the performance difference between Compute Cloud and other cloud providers, but what's the performance difference, if there is any, between the compute server and App Engine?
That's a great question. So I think you're comparing apples and oranges, right? there's no such thing as a compute engine performance, right? You deploy Apache, you deploy Node.js, you deploy something else. Performance varies, right? It depends on the entire stack you build. With App Engine, you get a fully managed stack where performance is taken care of for you, scalability is taken care of for you. So think about sort of the platform versus the infrastructure. So you can do a lot of things with Compute Engine, but if you write bad code, it won't do very well, right? So it's kind of, you just can't compare the two. It's not a fair comparison.
I mean, we invite you to try.
Yeah.
If you have workloads that could be suited for either, then you know, if you want to manage the infrastructure and you need that control, then Compute Engine is probably your choice. But if you would be happy with having all that managed for you, and you get the performance and the price points and everything else, I mean, all the different factors are what you want, then you should make that trade-off, right? So we offer multiple products so you can use whatever is best in your particular situation. Right, over here.
Hi, you mentioned that security was sort of like a major point of Google Compute Engine. I was wondering when you might be going through any of the certifications, for example, FedRAMP?
So the ISO 27K is probably one of the most common certifications around information security. And I didn't mention it today, but we actually have recently gotten ISO 27K certification. So that's one of the areas we've done. We're also looking at additional areas where certification matters to our customers, and you'll hear more about that in the days and months to come.
Anything specifically on FedRAMP?
I am not sure about that, but if you come and find me at the sandbox, I'll get you an answer.
Thank you.
Right, over here.
If I want to connect from Google Compute Engine instance to the Cloud Datastore product, is that going to have better latency significantly compared to connecting to that from another cloud?
In general, connecting from Compute Engine to other Google services, you're going to get the fastest connection from within Compute Engine. Not everything is hosted everywhere. These things have physical locations, and there's the speed of light. But we're continually working on optimizing the connection between Compute Engine and other Google services, whether they be cloud services or other APIs or services at Google.
And you know, as you access other Google services, your traffic stays on the Google network. So you know, it won't be subject to, you know, the variance in the general internet in those cases as well. All right, over here.
So beyond Debian and CentOS, anything for Ubuntu or Microsoft OSs?
So right now, our focus is on working with the community to provide community-supported distributions as part of our images. We've worked with both the Debian and the CentOS communities to bring those images to Compute Engine. We'd be happy to engage with any of the other free Linux providers who want to make the images available sort of as part of our default images in Compute Engine. In terms of Microsoft, we've heard that from customers. We'd love to chat with you more about your use case and see, you know, where that falls on our priority list.
Great, thank you.
Hi, my question is the App Engine data store being renamed or rebranded as Cloud Data Store? If the answer is yes, how do I get my existing data that is being accessed by an App Engine application to be accessed from a Google Compute Engine application? If the answer is no, how do I copy the data from an App Engine data store to the Cloud Data Store?
I actually don't know. I think, why don't you grab us afterwards and we'll find the right people who can give you that
I will
answer.
hang around. Thank you.
Is there a session on the app?
Yes, there's definitely a session on Datastore.
Yeah, and I think you definitely, you know, go to that session and they're going to go into the Cloud Data Store a lot deeper.
But you can also find us and we can, you know.
Yeah, we can find the right person.
I just need, I think I know the answer, and I think it's the answer you want, but we need to verify that.
I will hang around. Thank you.
You talked about the advanced routing. Is it very similar to your favorite competitor's virtual private cloud, or it's not there yet?
Advanced routing, so in general, I would think of advanced routing. So, you know, if you've looked at the abstractions of Compute Engine at all, there's always been this hint that there's this virtual router behind the scenes, a software-defined router. We never gave any knobs and sort of, you know, ways to configure it. And so advanced routing actually makes that virtual router configurable by you. So it lets you do all those things, but it's not a hosted service per se that does higher level things. It gives you the tools so you can do the stuff yourself. So it's very powerful, but it takes some work on your part. But you can do a lot with it. Does that answer your question? Yeah. Thank you.
I'd like to add to that, that I assume that you're referring to some service that starts with a V. That particular service is very complex. Compared to that, routing is very easy to work with. That's been our experience.
Okay, thank you.
So I apologize, we're out of time. We'll just head to the back, and you can chat with us outside if you have any more questions.
All right.
Thank you.
Thank you again for attending.